Okay, good afternoon, everybody. My name is Giorgio Marfella. I'm the chair of the Registration Board of Victoria. And as always, we have another webinar today. And before I begin, I would like to acknowledge the traditional owners of the lands in which we are meeting today. I am in the land of the Wurundjeri people of the Kulin Nation, and I wish to pay my respects to the elders past, present, and emerging. So again, welcome back. We have a seminar today, a webinar that talks about whole of life carbon, and in particular, we are interested in aspects that, as architects, you can embed in practice, as well as the implications that of the commitments that we have embedded in a National Standard of Competency that informs both practice as well as education for students of architecture. So I'm very pleased to be hosted by two guests and two colleagues, I should say, also from an academic perspective. The first one is Dr. Dominique Hes, who is the principal at Geronimo Advisory. Dominique also was former academic at University of Melbourne, and she was involved in developing the AIA training on embodied carbon. And then we have Philip Oldfield. Philip is the professor of architecture and head of school at UNSW in Sydney. And among many other things, Philip has also contributed into some aspects that are in the NSCA related to embodied carbon. Now, this is an opportunity for formal CPD. As always, you'll find there's a QR code that you can scan along the way. As you know, most of you, of course, CPD is mandatory in Victoria and it's audited by the ARBV. So this will be valid for one formal point of continuing professional development. Now, as always, I'll hand over now in a minute to our guests, but I'll be back towards the end to moderate some questions you may have. You can leave them on the side in the Q&A button. So with this, I'm done for now, and over to you, Dominique.
Thanks, Giorgio. We do have the QR code for you on the next slide, but I just wanted to add my own very brief acknowledgement. I'm on the lands of the Yalukit Willam as part of the Kulin Nation, part of the Boonwurrung tribes, and it's Manameet season now, cold, chilly, misty mornings, going into Barring, which is winter soon, and paying respect to the wisdom of the land and the seasons is kind of part of the way I ground myself. And Phil is, did you want to do any quick acknowledgements, Phil?
I'm on Bejigal land. I'd like to pay my respects to elders both past and present and extend that respect to any First Nations peoples who are online, maybe joining us, whatever country they're on today.
And if you are, how awesome, and thank you so much for joining us. So here is the QR code. So if you want to get the CPD points, there is a quiz and some questions that I've come up with that are based on some of the content we'll cover today. So hopefully that is a good confirmer of your learning as a process. So what we're running through, and Phil and I will have a little bit of more of an informal conversation as we go through, because a lot of the work that we did for the AIA Embodied Carbon project was informed by all of the wonderful work that Phil has done and others. So we'll do a little bit of what is embodied carbon, what is whole of life, what's the terminology. Phil will talk a little bit about what the latest is, and then we will have a conversation around the National NSCA, just the various elements that include embodied carbon, LCA and sustainability in them, with some hints and tips. But we'll see how we go as we run through the content, how much time we'll have for that. But you will get a copy of these slides, and the slides will, hopefully, if there's anything that we won't get a chance to talk about, you'll be able to reference them. So the AIA Embodied Carbon curriculum is, I'll run it through what it looks like in a second, but this is the link to it. Now I've got note, this is set to change because the AIA is sort of formalising all of their training processes like other organisations, AICD, etc., where, you know, you have the content and then you have a quiz or something that happens. And so this website is still relevant as of today, but may not be over the next few months. So while it's free and available, jump in and do it. So why is it all are people talking about embodied carbon? Why is it an issue? And mainly it is that as we reduce the carbon intensity of our operational phase of our buildings, and I'll show you some images of that in a minute, the material use has a greater and greater impact. But we also need to balance, the carbon in materials. So you could make a building that lasts a really, really, really long time, but is really high in embodied carbon and might use a lot of energy. And even if your energy hasn't got a lot of carbon, it could still require a lot of solar panels and so forth. And so there is a balance that's needed. And obviously, people have budgets, people have constraints. And so we need to be able to have this embodied carbon conversation in context of everything else that designers need to achieve. So why is it an issue? Summarising a graph. At the moment, and I'm sure, Phil, you use similar images up in New South Wales, but operating carbon's about half of the combined upfront carbon. That's the carbon that goes into building the home, and the recurring embodied carbon. That's, when you replace your carpets and repaint your walls, etc. Put in a new hot water system like I just did. So that's your recurring carbon. But by 2050, expectations are that this is going to change. Anything, given that this is your work, Phil, that you'd like to speak to?
Yeah, look, I think, when I go back about 20 years and I started my research on embodied carbon, the general consensus was embodied emissions are about 10 to 20% of a building's whole life cycle emissions. And we've seen that change, as Dominique said, to about 50-50 today. It's a good starting point, it's 50-50. That's going to depend on the state you're in. In Tasmania, embodied's going to be a bit more because the grid's already decarbonised. In other places around the world where the grid is less decarbonised, it might be a bit less, but it's a good starting point, kind of 50-50. And we expect it to be 60, 70, 80% in the coming decades. And this graph is my visualization of what actually the carbon footprint of a building looks like over time. And you can see in 2023, assuming a building's built, you've got this what's called initial embodied carbon. You've got to build the building in the first place. Then you can see over time, you've got these inclines, and that's operating emissions that are building up over time. Operating emissions are cumulative. Each year, you will emit carbon. Then after 10 years, you maintain your building, you change the carpets, as Dominique says, you change your mechanical systems, you upgrade a few things, so you get a little blip. That's recurring embodied emissions, maintenance, repair, refurbishment. Then the operating keeps going up as well. But you'll see those operating lines start to level out. And that's because we're decarbonising our electricity grid. So the amount of emissions associated with operating energy is decreasing over time. In New South Wales at the moment, every kilowatt hour consumed of electricity is about 0.79 kilograms of CO2. That was 0.86 a few years ago. So we are seeing that go down.
Right. And why is this important for you as architects and within your competency? Is because the decisions that you make right here in 2023 in what goes into that building on 2026 as of this year, those decisions really make an impact on that operational and that embodied carbon. And so understanding what embodied carbon is and what your role and responsibilities are is part of the reason for this webinar and those competency requirements. So going back to the AIA embodied carbon course, so the intention of this course is to really produce a foundational understanding of what is it, why is it important, the terms and concepts, how you measure it, how it's calculated, talk about some best practice case studies, how you improve it, what does it mean in your day-to-day practice? And the last module is around innovation. So that's how it was designed, and currently this is how it looks within the AIA system. As part of joining that course, you do need to sign in, and if you're an AIA member, then you can go for your get your CPD points as part of that. If you want to do it for free, then you don't get the CPD at the moment. And there is a roadmap, so a one-pager. There is a toolkit that's kind of a summary of all of the information that we had. Now, we wrote this before NABERS came out. So doesn't include, the course itself doesn't include NABERS. I do have NABERS here for you. So this is already a little update on the AIA course. But that's how it works. Each of these is meant to take you about 45 minutes to work through, and there are some reflection exercises for you to do. We ran this with groups, and so there were some group activities. So you just need to navigate that. So who was it developed by? Caroline, Amanda and I collaborated on the development of this across a couple of months. It was funded through the Australian government, and then we harassed a whole bunch of friends, including Phil, to help us to make it as appropriate and effective for architects as possible. So with thanks to Davina, Jorge, Paul, Andy, and of course Phil, who's with us today, and the funders. So jumping in, and a lot of this has again been informed by Phil, and in the next slide we'll go into the famous diagram that really outlines all of the different steps. But I just thought we'd start with an idea. So as we're going up, so we start here at the bottom, it's 2023 or 2026, and you do some design, and the construction starts, the materials start coming to site, and those materials have a certain amount of embodied carbon. So it's the amount of carbon it takes to make that material. If it's a brick, to get the resources out of the ground, to form the brick, to bake the brick, and then to deliver it and to build the brick, put the mortar on and so forth. So that's what we call embodied plus upfront. So then we go into the use stage. So the use stage in Phil's graph that he just showed are all of those steps where you're using the operational, and then a little blip as you add a new hot water system or whatever, carpet. And so that's that 50 to 100 years of operations. And then we have end of life. End of life is whatever happens to the materials of that building at the end of life. Does it go to landfill? Does it get reused, etc.? And then there is a stage which is the beyond the life cycle, which is, after that gets taken off by offsite, what happens to it? And so that, in some cases, can give you a benefit, and sometimes that comes through. So what that looks like in this famous diagram from the standards is this. And this is meant to outline as simply as possible all of those different stages that I ran through just briefly in the previous diagram. And so we have all of the embodied carbon, which is this green line that sits around here, and it excludes the operational energy, and usually excludes the out-of-scope parts of the operational water use. So it's really just your gas and electricity usually, and then the whole of life runs across everything, but excludes those benefits components. And that's because there is very little control that you can have around that, what happens at the end of life. And so within the standards, section D is not included. Anything you want to say to this diagram, Phil?
No, I think that covers it all, but I think it's a really powerful diagram because the terminology sometimes can be used interchangeably. So, do you include end of life emissions and embodied carbon? Sometimes people do, sometimes they don't. Better to say upfront emissions. So it's really, really clear what that is.
And I'll be using this diagram, everyone, when I talk about Green Building Council and how they bring embodied carbon into their standards, to kind of show you how this diagram is so meaningful and important to understand what's made up within it. So the GBCA brought out a great paper a little while ago, which was a practical guide to upfront carbon emissions, where they talked a little bit around the terminology of embodied carbon and broke down where embodied carbon comes from. Now, why this is useful, excuse me, I shouldn't have had that drink of tea. Why this is useful is because it gives you a sense of, okay, if you're, as a designer, trying to think about how do you reduce your embodied carbon overall, where are your focus areas? So, 10% finishes compared to 42% superstructure, then you can say, okay, well, let's put in some effort to understand where the superstructure impacts are and what we can do about that. So it gives you a sense of where you could prioritise. Interestingly, transport and construction's in there. So thinking about the relationships you have with your builders and what impact you have on that through your clients, as far as, there are builders out there that are reported to be carbon neutral, so they use either offsets or renewable-based electric systems to do the construction and so forth. And so you can start building on those relationships through that. Another way of talking about, and again, Phil has developed a lot of the work on this, but one of the other terminologies that people use when they talk about embodied carbon or carbon from a process is scope 1, scope 2, scope 3. And we go into this in quite a lot in the AIA training, but I'm not going to spend a lot of time on this. But scope 1 is what's released on site. So if, oh, Giorgio got thrown out, let me admit him again. Those are the emissions on site. And so that's if in your home, if you're leaking refrigerants out of your air conditioning, or if there's a gas leak or whatever, that's what that is. Scope 2 are the things that are released off-site, but it's because you're running things in your home or building. So if you're running the lights and you're getting energy from off-site, not from your own solar panels, but from a coal mine or renewable energy somewhere, then that is scope 2. So you take that as a scope 2. Scope 3 is your indirect emissions. And this is important because a lot of the bigger organisations are needing to start to report their scope 3 emissions. And for other organisations, if they're commissioning a new building or in a new building, then the embodied carbon within that building is part of their scope 3 emissions. And so they will be looking at how do we move towards a zero carbon building that we can commission, because that then means that they can have less of a burden to report to their shareholders. Anything you want to say about this, Phil?
No, I think you've got it absolutely right. It is used, it's a different way of using terminology, but just understanding the basics is sufficient here, I think.
Yeah, so the key thing, takeaway for this for you all, is that the reason that people like GPT, Lend-Lease and so forth are starting to ask you about embodied carbon is because that they need to start reporting that to their shareholders. And so this is a reason why this is important to know and understand and manage within your design practice. So very briefly, I'm sorry my little white box has gone over the text a little bit. I just wanted to explain how it's measured. And so some of you might know, but back in the 90s, the mid-90s, I was an LCA consultant in Europe. And so the calculations of all of this has been part of my practice for over 30 years. But to work on understanding the embodied impact and LCAs of products. So if I'm talking about my cup of tea here, there is a certain amount of materials within making this cup. And then I need to multiply that by the impact of those materials have created. And so in the case of a building, you end up needing to have a bill of quantities where you understand the quantities of your various materials. So that's what you need to start with. You need to start with a bill of quantities. Now, my experience within the last 20 years of working with architects is that your initial design ends up being different to what actually gets built. And so that is part of the process that needs to be thought about if you are aiming for a low carbon outcome, is that paying the attention to actually getting the materials that you've specified because they're low embodied carbon, and requiring alternatives that meet that same standard is important. And again, we cover that in the AIA course. So anyways, you've got your bill of quantities, you've got your amount of materials. So that's the physical amount of the materials used. Then you apply a factor. Now that factor is based on kilograms of CO2 equivalent units. Now, the equivalent bit is that we tend to use CO2 as our equivalent as 1. But some emissions like your refrigerants will have a much higher impact compared to CO2. And so it is a certain thousands times CO2. And so that's what that equivalent. So it's bringing everything to the same value. And so that's what carbon CO2 equivalence means per unit. So per unit would be per metre squared of concrete, kilogram of steel, etc. Now, the thing that is the most useful place to go for information if you're choosing materials is what's called an EPD, and that's your environmental performance data sheet. But there's also resources such as Australian LCI, Neighbours and Green Star databases that has some of this information, and they will have extracted it from EPDs. EPDs are produced by the producer of the product. Whereas these databases, Neighbours, Green Star, are taking the bits of the EPD that are useful and putting it into their database. They tend to include upstream processes, things like extraction, processing and manufacturing. Then you multiply one by the other. Yeah, so you have a spreadsheet of materials, you've got the factors to those materials, you multiply one by another. Then you add A4 and 5, which is your transport and your construction. And then that gives you your total CO2 per metre squared. You divide it by your gross floor area. Within the course, we do talk about some databases work on gross floor and some databases work on net floor area. And so that's something to keep an eye out for. Anything you want to add to that, Phil?
No, it's misleadingly simple, isn't it? It's a quantity of materials times by a coefficient. And despite that causes a huge amount of concern with people, I think. But in reality, it's a relatively simple piece of mathematics to work it out. It's just often we don't know what quantity of materials go in buildings until they're built, which means it's difficult during the design process. And then there's a question of where do you get your emissions factor from? Lots of different databases. I'll talk a little bit more about the need for transparency around that, because depending on where you get it might influence the kind of result, and we want to be sure we're comparing apples and not apples and oranges.
Exactly. So here's just an example of what an EPD, where the EPD database is. So again, you'll get these slides and you'll be able to jump in there, but you can go in there and you can look for information. Obviously, there is a problem if you want some products and they're not in here. And so then again, you're potentially not comparing apples with apples. And so there is an international, which I've referenced there, EPD database as well. But always try and go for the local data first before you look internationally. One of the things that an environment performance data sheet has is it doesn't just have your carbon. You can see here your climate change are at the top, and within the course, we don't have time today, I actually go through and explain the difference of these, and we do some activities around how to calculate them and what you choose. But unfortunately, it isn't as simple as just a total. There is some nuance around that, particularly around the biogenic, and I'll talk about that in a minute, which is if you're using timber and you're storing carbon in your building, then that can be a benefit depending on the assumptions that you're making. The other point to make with this is that environment performance data sheets are based on LCAs, and LCAs aren't just about carbon. They are, in fact, measuring the impact of creating that product across all of as many as we deem important impacts on the environment. So things like ozone layer and acidification, acid rain, eutrophication, that is increased nutrients in the water and so forth. So there is a lot of stuff that gets considered in an LCA, which isn't necessary for just the embodied carbon component, which is why the Neighbours and Green Star and LCA Australia are so useful, because they do help you to focus on the right factor to use without having to understand EPDs. So very briefly, before we jump into Phil's part of the talk, I just wanted to briefly deep dive into Neighbours. So we're all aware of how Neighbours works, particularly for commercial buildings in the operations space, but they have brought out an upfront embodied carbon. Now, remember in that diagram, the upfront is the bits that are really in your control as architects. So just like it does for operational energy, indoor air quality, water, it provides a certified comparable way of measuring the intensity of your buildings. And I've briefly talked here about the stages, and I've talked about the bits that it wants you to report on. So the main structural materials, the major mechanical systems, and the as-built quantities. And again, this is the complication between being at the architectural side, where you're designing what you'd like in there, and then what ends up being built. There can be some substitution. And so that's one of the nuances that you need to think about in your relationship or documentation for the builders. It does what we went through before. It calculates kilograms of CO2 equivalent per metre squared GFA, and it gives you a 1 to 6 rating, which we're pretty used to. The suggestions, if you want to minimise your embodied carbon and maximise your star rating, is substitute with lower embodied materials, make sure you do structural efficiency, look at steel timber mixtures, the timber being very low embodied carbon, even if you're doing the biogenic, can be positive. Reducing the finishes and smarter facade systems, What I mean by that is, if you want to think about your building holistically, and you want to ensure that it lasts for as long as possible, thinking about the finishes that you use have an upfront impact, but can also have a reoccurring impact. And so thinking through those. And then, get local materials, prefabrication and so forth, so that you're minimising that A4 and 5. Jumping into GBCA, so if you're going into get a Green Star rating, then they're looking for data on upfront carbon and full LCA, depending on the credits that you're going for. And what they're looking for, as Green Star does, it's looking for you to produce, above and better buildings than average. So you're looking at requiring at least a 10% reduction in upfront carbon certification. And if you really want to go to the higher end of the points, you want to look to a 20 to 40% reduction. And it is a shifting scale within Green Star. Over time, it'll get harder and harder to get the higher star ratings. The LCAs run across a larger, because it's trying to look at the whole of life assessment and carbon for the building. And so it brings in the B category, the use, the C category, the disposal, and D potentially, depending on the challenge and how many points you're going for. So what I've done here is just quickly run through this to try and show you within this diagram. So for the GBCA, the credit pathway for upfront carbon is really looking at manufacturing, materials, transport and construction, and that's that stage of the whole life cycle. So it's the A1 to A5. If you're going for the whole life cycle impact, then it's taking A1 to C4 plus D, and so it's looking at everything. So except for D. So it's looking for all of the materials across A to C, but it's also bringing in that operational energy use and the energy use for the materials for the water side of things. A climate positive pathway, that is B6, and so that is just narrowing into the operational energy bit. So that is, that demonstrating that will be offset and renewables based. And then last one is your carbon neutral pathways for everything, which is, how do we take the upfront, the life cycle and the climate positive and bring it all together and offset everything. So that's what we've got there. And so really the aim of this is to say, within understanding your responsibilities as architects, having a think about how you deal with embodied carbon and the information that you start collecting and bringing into your practice, which we focus on in the AIA course, is really important. Phil has put together a whole bunch of tools that are available. The GBC Upfront Carbon Guide also talks about a whole lot of tools. So there are tools out there that will help you to start calculating that embodied carbon in the background as you're doing design work. And that would be a good way in that early ideation stage to really start thinking about how do we move towards a zero carbon building. Within the course, we also provide a whole bunch of resources. Again, this is the current link to that, but it may change in future. So over to you, Phil.
Thanks, Dominique. So I'll talk you through a little research project we did. It's pretty practical, though, really. It's based on a real building built in Australia. I do want to shout out Gerard Reimer from Terroir. He initiated this project. It's on one of his buildings, and he kind of partnered up with us to ask, well, look, we've designed this really cool and really sustainable building. How low is the embodied carbon of this building? What other things could we have done as an architecture practice to make it reduce the embodied carbon? Next slide, please. And we were influenced by the kind of targets we're facing globally. So the World Green Building Council have given general global targets of embodied carbon reductions. And they say by 2030, all new buildings must be net zero operational. Now, if a building's net zero operational, all the emissions are embodied, which is quite significant. But then saying all new buildings, infrastructure and renovations should have at least 40% less embodied emissions as well. So compared to now, we're already dropping 40%. And then by 2050, all new and existing buildings should be net zero operational, and all new buildings, infrastructure and renovations will have net zero embodied carbon. And this is about 8 years ago now, but no one really knew what net zero embodied carbon is. And still there's a lot of debate over, is this possible? What does it look like? And so we want to talk a little bit about that as well. Next slide, please. So we asked 3 questions. 1, what magnitude of embodied carbon reductions are possible for an office building? This was an office in Australia, and what materials and systems can influence this? And I've written down the PCs from the NSCA that these refer to as well, just to kind of guide our conversations later. Secondly, how can different methodologies and data sources influence this? So where do we get our data from, and what's the impact of that on the outcome? And finally, what is net zero embodied or whole of life carbon, and can it be achieved? So next slide, please, Dominique. And so this is really important. So the building you see with the red dotted line, this is a kind of 8-story timber building built in Tasmania by Terroir. And they just finished the building when we kicked this off. And we called it BP, we called it best practice, because it was really the best practice building you're going to get. Concrete cores, timber floors, columns and beams. The ground floor, the brick, was all reclaimed and refurbished, existing. And so it was a kind of super sustainable example. But what we did, we worked with Terroir to design a TY, which is typical, an all concrete version of this, making it really, really simple. Then we did 2 different versions we called ST, which are stretch versions. The first ST version, we took out the concrete core and replaced it with timber. So we did an all timber structure, and the top 3 floors, we took out all the glulam and replaced it with basically stick frame. So put a stick frame building on top of a glulam building. And the final one, STW-STC, we used, also the standard ST, we also put straw in the facade as well. So we insulated it with straw. We started throwing the kitchen sink at the kind of design aspects. The final one uses the lowest EPDs we could find, as much recycled material as we could find, and we absolutely went kind of full game on it. Every trick in the book we could play. You'll see we also reduced the amount of glazing to replace that with timber to increase the amount of biogenic materials in there. And our question, was how low can we get things? Next slide, please. And as I said, we use data from 2 different sources, one from EPIC and one from EPDs. Now, EPIC is a great Australian database. Without getting too technical, they measure embodied carbon coefficients using a hybrid system, which is very, very complete, really, really complete in terms of downstream impact. So if you think about mining iron ore, they'll be considering the embodied carbon of the tire in the digger that's picking up the kind of iron ore as part of that downstream. EPDs are more particular they're not as complete, but they're very specific for a particular product. So they are very different. And as you can see, we got very different results. So the typical building with EPIC was 832 kilograms of CO2 per square meter. This is A1 to A5, whereas with EPDs, it was 520. So really big difference. And this is why it's really important when we're doing these kind of calculations or when we're commissioning them to ensure transparency. And it's also really important, the move for neighbours to develop a consistent national methodology, because a couple of years ago, if you give me a building and an embodied carbon, I couldn't tell you whether that's low or high, because unless I knew how it was calculated, what data people had used. And so this is why we've got to be a little bit cynical and a bit cautious with when we see these numbers bounded around, unless they've been done through a consistent pathway. So we're measuring apples with apples. But in short, look, we could only save 17% of the embodied carbon with EPIC. We could save 45% with EPDs. Again, where we get our data from influences the kind of outcomes. Next slide, please. One of the big things here was how EPIC and EPDs dealt with timber. And so glulam in EPIC was 1,718 kilograms of CO2 per cubic meter. And with EPDs, it's typically 200 to 400. So a factor of kind of 8 difference in the embodied carbon of a material, just because of the different way it's measured in these databases. And one of the outcomes we found is the graph on the left is A1 to A3, so just materials and just structure. The blue is EPDs, and so when you switch from concrete, which is typical, to timber with best practice, it goes down from 251 to 201. But with orange, with EPIC, when you switch from concrete, that's 344, to timber, it's 371. So the timber building actually has a higher embodied carbon than the concrete building. And I'm not saying which one is right or which one is wrong, they're different, but it's really important, again, about that choice of database and that choice of method, and then that's transparently communicated and consistent so that the decisions can be interrogated correctly. Next slide, please. So this is just EPDs. And then we measured, this is A to C. So upfront embodied carbon, recurring embodied carbon, and end of life. And you can see the concrete building was 918 kilograms of CO2 equivalent per meter squared. The best practice, we got it down to 812, but the stretch scenario, we got down to about 603. And one of the biggest things we found is just switching from concrete to timber had a modest impact. But switching from concrete to timber and changing the grid, so we went from a 9 by 6 meter grid to a 3.6 to 6 by 6 meter grid, so we could design out the glulam beams, had an enormous kind of impact. And one of the biggest things we found is actually having more columns in the building. It sounds kind of perverse, sounds counterintuitive, but you add more columns in, you can reduce the floor to floor height, you can reduce the slab depth. And it's actually, in multi-story buildings, it's a floor system that's a big contributor to embodied emissions. Next slide, please. This is a graph by ARBV, for example. This shows span against embodied carbon. If you take the blue line in the middle, the general values, a 7 meter span structure will have an embodied carbon of about 150 kilograms of CO2 per square meter, just a structure. And you go up to an 11 meter span, it goes up to 250, 260 kilograms. So you can save 100 kilograms of CO2 per square meter by reducing the span. Now that becomes a design challenge. That's an architectural challenge. It's not just a material substitution challenge. It becomes a conversation with the client about how will they lay their floor out, their commercial floor out with more columns. I'm regularly telling my students and architects, we need to hug a column, you know, make columns great again, because it's one of the simplest ways we can reduce embodied emissions, because in multi-story buildings they're all in the floor system, or a huge amount are in the floor slab and the floor system. So anything we can do to reduce that will have a big benefit. Next slide, please. So we did a lot of different design factors on this, some material substitution, some more substantive design changes. This is a waterfall diagram that shows what some of those kind of are. And quite confrontingly, the biggest, most effective strategy was removing the carpet. Now, why would it be removing the carpet? It's because of the recurring emissions. So we built into our model that carpet was changed every 10 years. So you put the carpet down in year 1, then by year 10, you rip the carpet out, you put it down again. Year 20, you rip the carpet out, you put it down again. So that carpet adds up about 5 times over the building's life. And so if you can remove the carpet, if you can dematerialize, if you can remove materials that are not going to play an advantage to the client and to the building, that's the best saving you can make in embodied carbon. Removing instead of substituting, for example. There's a potential we slightly overestimated the carpet because we're assuming the same embodied coefficient now as in 10 years, as in 20 years. And effectively that will go down over time. But the kind of point stands that recurring emissions do add up, but they accumulate over time. The second most effective strategy was switching to a hybrid timber curtain wall. Pretty kind of high spec stuff, but the idea was aluminium on the outside and hardwood on the inside, curtain walling. So that reduced the amount of emissions. And the third most effective strategy was switching to timber and reducing the column span. And there's other little bits in there as well. So reuse of existing walls saved 11, reducing the window to wall ratio saved 17. So there's lots of little bits of ways. And the other thing is there's no one way to reduce embodied carbon. Often you're just scraping little things off and just getting, you know, accumulating the kind of savings as they add up. Next slide, please. And look, the next question we asked is, how do we get down to net zero embodied carbon, and what does that look like? And when I envision what a net zero embodied carbon looks like, this is the closest I could come up with, because you've got some energy to build the shed, but there's not a lot of steel and concrete going on, and the biogenic emissions, the timber has stored CO2, and so maybe that offsets it. So we asked, could this building do the same? Next slide, please. And without getting into kind of high school chemistry territory here, what we're looking at is the different kind of carbon profiles of concrete and timber. And if you think about a tree, you plant a tree, that requires a bit of energy, requires a bit of emissions, but then over time, the tree photosynthesizes, absorbs CO2, releases oxygen. And so you can see the blue line on the graph there, the emissions are going down into negative territory. And you cut the tree, you turn it into a glulam beam, you glue it together, you put it in a building. That timber has absorbed and has stored CO2 during that time, and you can count that towards embodied carbon if you're careful. But you can see at the end of a life, if you burn that timber, releases all those emissions straight out. If you landfill that timber, slowly releases it over maybe 200 years. If you recycle that timber, that's great, but the next building gets that benefit, so the benefit's passed on. It's a lot of complexity there. Concrete is very different. When you make cement, you heat up limestone in a kiln to create clinker that chemically releases CO2. So you get this big burst of CO2 emissions up front. Interestingly, concrete absorbs CO2 from the atmosphere during its life, so the emissions drop down a little bit. That's called carbonation. You probably don't have to worry about calculating that too much, but you can see the profile of the two is very different. And one of the things we wanted to look at is, can that stored carbon in timber get us down to net zero, and what does that mean? Next slide, please. And we found it could. So we took the best, that straw timber building, the best version possible, and we found that building would store about 230 kilograms of CO2 per square meter in the building. And then if we use the lowest EPDs we could find, it was about 200 kilograms of CO2 to build the building. And so effectively, for the first 19 years of the building's life, it would be temporarily net zero embodied carbon. But there's a concern around this. And our concern was, well, why don't you just throw some more timber at it? What happens? And so the building was designed with a 250 mil glulam slab, CLT slab. And if we doubled that to 500 mil, totally structurally unnecessary, the building's emissions would actually go down. And so you end up with this very perverse scenario where you're adding materials into a building and the emissions are going down. And that's why most methodologies ask you to calculate those biogenic emissions separately and to report them separately. So a better way of saying this would be to say the embodied carbon is 200 kilograms of CO2 plus there's 230 kilograms of CO2 temporarily, or by long term, stored in the system. Next slide. And so look, what we found is that large reductions of embodied carbon are possible, but just switching to low carbon materials has a modest impact. It is a design and architectural challenge. It covers design, layout, other factors, as well as just material substitution. Look, there are modeling challenges around appropriate data sources. Key thing is being transparent, being open and honest and transparent. Where data came from, how you calculated it, I think is pretty key. I see a lot of reports and I'm going, where did they get the data from? And so the more transparency we can add, the better. And this idea of temporal net zero carbon embodied carbon is possible, but it relies on a bit of creative accounting. It's not always good. So generally I say report biogenic stored emissions separately. Still report them, they count, but be careful about how you include them in the kind of outcome. I think that's me done, Dominique. Over to you.
Yeah, well, now it's really, we've got 15 minutes left. Giorgio keeps coming in and out, so I think he's still having trouble connecting. So what I thought we would do is basically quickly run through the competencies and just give our top tips for each one. You already did some of that in your slides, which everyone will get. This was just me saying, okay, this is what your requirements say. From this talk, what you want to do is take home is you want to minimize your carbon impact. Why? Because carbon's having an impact on our climate, which will have an impact on our future capacity to thrive as humanity. Carbon neutral is some language that you need to get used to and work out what your responses to that are. Holistically, think about your building not as just what it will be like in the design, but how it goes through life. And so thinking about things around longevity, upgradability, and so forth is really important. Analyze your impacts and think about that circularity potential as well. So here, the NSCA frames sustainability as core ethical component for architects. And so it really is important to think about, this is not just about an extra thing that you have to report on. It's actually part of your ethical requirements as an architect to think about these things because it impacts future generations. So PC31, I've just repeated what's in there because it's really hard to see so small. But within this, the embodied carbon and carbon emissions over the life cycle of the project need to be understood. And so my top tips, Pete, Phil, if you want to add, simplify your material palettes and look for recyclable or reusable materials. Think about things such as, and we talk about it in the course, materials passports and so forth. That's a way of people knowing what's in your building when it gets broken down at the end of life. Don't no longer talk about end of life as demolition, but actually about resource recovery. And think about your bio-based materials, as Phil's already gone through in a lot of detail. Any top tips for PC31?
No, I think you've covered them all there. But I mean, I'm just looking at the Q&A. There's a question in the comment about I get told off for talking about carpets too much because we were moving carpet. So the key thing is we have to balance often multiple competing factors. Yeah. You know, if we're just trying to create the lowest carbon building, well, don't build anything. And often we can't. You don't want to remove materials and reduce performance in another aspect as well. So a lot of it is this kind of balancing act as well, which I think architects with our kind of systems thinking are well placed to interrogate.
Yeah. So PC35, I won't reread what's in the boxes there. Just know you'll get those as a slide. But here, my top tip is EPDs are your friend. Things like Neighbours that have and Green Star that have taken the data from those EPDs and translated them for you are really useful. Yep. Do the AIA course. I think, you know, we've had 45 minutes here with you. There is a lot more to it. Yeah, work towards understanding the terminologies, the tools, build trusted partnerships and understandings with consultants, with your suppliers and with your builders. And again, EPDs are your friend. And then, yeah, use that ideation and analysis tools to start thinking about the implications. So what Phil has presented around the thinking about spans and so forth, there are a few of those out there, tips around how to minimise the inherent embodied carbon because of design decisions. So think about that early, but also think about comfort, longevity, function, and outcomes. I'm just going to jump through these really quickly, Phil. I'll just yell out if there's anything you want to add. PC 45, again, EPDs are your friend, but also look at other tools such as Living Building Challenge has a red list and declare products. That's another source of information, but it also reduces the toxins that you could be specifying. And look at the future. We have a whole module that in the course, but look at the future of nature-based materials. There's a lot of stuff happening within that. Remember that LCAs don't just give you the carbon, but give you a whole lot of other things, including eutrophication, toxicity, and so forth. So LCA is beyond carbon, and so that is something to remember. PC 53 is the implications, and so this is more of a design understanding of your decisions. And so, and that is also about ensuring that what is specified has alternatives outlines. And so in the course we talk about if you've specified a brick that has this many tonnes of CO2 per pallet, then put that in your specification so that any bricks that might get substituted meet the same requirements. And don't forget to integrate lifecycle costing as well. That's the eternal argument, isn't it? OPEX versus CAPEX. Again, not something we have time to go into. And then lastly, PC 60, which again talks about the life cycle assessment. So remembering that it's not just carbon. And so my top tips are simple, keep your building simple, use local materials, try to be as natural in your material selection as possible, ensure that they are recyclable at the end of life and, if possible, reusable, and design buildings that are wonderful and people will love and look after. So that's us. Shall we jump into the questions for the last 50 minutes?
Yes.
Giorgio, you're back with us.
Yes, I'm back.
Awesome.
Sorry.
Over to you.
So I've been on and off, apologies, but I came back just in time. So let's go through some questions that are very interesting. I already browsed through them. The first one is, what incentives can be provided to owners and developers, I suppose? Because, you know, architects, of course, got all the goodwill in the world, but, you know, often the client determines these things. Any suggestions?
Well, I think that neighbours will hopefully change. It's just like it started to, well, not started, but had a huge influence on the operational side of things. I mean, what we found is, you know, your top commercial clients want to get the 5-6-star neighbours, and that becomes commercially essential. It's taken a few years, of course, and I think the star rating in neighbours will be a great incentivization for certainly for the commercial sector. Residential sector is a little bit different because it's obviously tied into the kind of political side of housing affordability as well, which is a challenge too. If you look around the world, there's some places have started regulating embodied carbon, putting caps on things. So in France, there's a cap. All buildings have to be embodied carbon within this much, and in fact they've set the caps for the next 10 years. It drops down every 3 years, so they can kind of keep track on it. And I think, you know, a regulatory framework may only be a few years away in this space potentially.
Yeah, I don't have anything to add.
Okay, thank you. Next one, NISO, I believe. It's a software measuring carbon, just launched in Australia this year. Any comments on that? Or it's just a comment, but some practice I use it. And on that, maybe I'll pick up on the other one. There was also a question on what kind of softwares can be used, particularly for sole practitioners, small practices. You know, it's a very specific area, but arguably it's also bordering competencies that require engineering, of course. You know, so any suggestions on tools that can be used by architects, particularly the low small practitioner?
While you're answering that, I'm just going to, I saw a question about showing the QR code again, so I'm just going to start sharing the QR code.
Yes.
So I can partially answer that. I mean, there's a huge amount of different softwares out there. I use Microsoft Excel because I'm quite, I like to see the numbers go in, and you can just multiply it through Excel. It depends how you design as well. So if you design in Revit and in BIM, there's lots of plugins for Revit, things like Tally. We teach the students at UNSW, we teach them Tally. We teach them by hand in the first year, so they do it via Excel in the first year. And the second year we teach them Tally because they all use Revit. And if they build a Revit model, Tally will pull the data kind of straight from the Revit model. So if you're designing in Revit, something like Tally, there's other ones as well. But if you design in other ways, it depends on, where you get your bill of quantities from. And I know now, bills of quantities are not generated in the kind of same way. They often pulled off BIM models. So BIM plugins tend to be quite common now.
Another question is predicted AI energy use. How can they be included in calculation for future building design?
It's a difficult one. I've seen emerging trends happen now. You can train models on part of what Neighbours has been doing, which has been really important. The past 20 years, past 10 years, we don't know what's a good embodied carbon or an average embodied carbon about. Neighbours have taken, I think, well over 100 buildings and benchmarked. And they've done it manually. So they've put 100 buildings in, and they now know what is typical for an office, what is good for an office, what is bad for an office, for example. There's a hope that, and there's similar projects happening in America, something called the Carbon Leadership Forum, in Europe through Martin Rock and his kind of group's work. I think there's a hope that we can train models very quickly to produce bills of quantities quickly in the early stage. So that would be quite useful, because the big challenge with embodied carbon is you need to know how much materials go in the building to do the calculation. And I think there's some AI training going on I've seen at the moment to try to say, hey, if your building's this big, it's typically going to have this much. Bang, we can pull an embodied carbon out. But it's still very emergent at that kind of level.
I think, Phil, the question is, so, okay, we all use AI, right? Let's face it, right? One way or another. So if you have a building, imagine a workplace, you have a component of people who might use the AI more than others. And that obviously is associated with data centers and all that. So it's almost like a pro capita kind of factor to build things.
Oh, okay. So I misinterpreted the question. Well, look, we might see operational emissions increase. All our future predictions, what I was showing, embodied emissions, operational emissions decrease. If your average office workers, making all their questions on AI, and that forms part of the office building. One of the questions out of this is what do you include and exclude in the measurement of a building? So if you've got an office worker and they go and buy a sandwich, do you include the emissions of that sandwich? It becomes slightly philosophical. Should you be including just the electricity from the laptop the office worker's working on, or do you include the electricity from the data center they're dragging their information from? It's a tough question. I don't have an answer for it, but it's one of those things that is being looked at. I think people are having discussions about it.
There's also, you talk about carpets. I suppose you probably very quickly want to touch a bit on this dilemma. So of course you favor particular materials for the aspects of embodied carbon, but then you might have other impacts like, or I'm thinking of fire as well. We spoke about certain materials. So just a few words, Dominique, maybe on what's the ultimate guideline we can give to architects? How do you juggle these competing factors?
So I think partly it is what you're talking to your client. Sorry, I got distracted by the question that asked if we could go through the questions of the formal CPD, running people through the questions. And I don't think in 3 minutes we have enough. Sorry, anonymous user. But feel free to reach out through LinkedIn or whatever if you've got confusion about the questions. So, sorry, can you repeat the question, because I was distracted thinking about how to best answer.
We're using the example of carpets in a question to say, well, we can reuse carpet and it has a good positive impact on carbon, but what about the acoustic implications? So, and this is something architects have to constantly juggle, right?
Yeah. Look, at the end of the day, a building that people hate because they can't use it because it's too noisy is a waste, right? So you could have the lowest embodied energy building, and if nobody wants to use it, it'll get knocked out in 5 years and something new will be built. So start with creating a building that people love, but do it in such a way that you minimize the impact of that building. And you do that by potentially sometimes investing more embodied energy to create the acoustic outcome, the visual outcome, the views, the connection to the environment and all that good biophilic stuff. So this is a balance and a dance. I would start with love of place and care of place, and then bring all of your skills to do the best you can within that scenario.
Another interesting question is here, how to measure embodied energy for excavation and earthworks. Is there any research on that? Because obviously, the more you excavate, the more, well, there's a machinery involved, I suppose. Potentially other aspects that I can't think of, but
so A5 is particularly difficult because you think of all the different machinery on site, the different diesel kind of equipment. Generally, we use, many different organisations will have typical usage. So organisations like the Royal Institute of Chartered Surveyors, RICS, and their methodology, Neighbours have typical data, GBCA have typical data. And my advice is generally use typical data because it's very difficult to model. You can spend a long time doing it. Where's the crane going? What energy is the crane using? Where's a particular excavation? What does that kind of look like? And so typically for A4 and A5 emissions, Neighbours have some really good kind of generic values to plug in.
And lastly, sorry, Dominic, did you have anything to add on that?
Oh, no, I'm getting distracted by somebody asking about question 7 in the quiz because I didn't give 7 questions. Will be fun. So I'm sorry.
You gave the right advice. Feel free to get in touch with the ARBV and we'll have
Yeah. Sorry, what was the question?
So the other question is last one. It's you spoke about geopolymers. So has there been any case studies on geopolymers?
Well, that was one of the reasons that we had Amanda with us because at the time she was running Built by Nature, so working with a whole lot of innovators in Europe around the by geopolymers. I am translating that into nature-based products of various types. And so we run through that at the end of the course on all of the options that are being developed. As of that time, 3 years ago, I know there's been some further innovations since then. We also run through materials such as hemp, concrete, and things like that.
Okay, yeah. So there is some research that obviously you can plug into, and obviously referring to experts like the dear colleagues we hosted today would be the first thing to do, I suppose. Be in touch. Universities and specialist advisors like Dominic are always willing to engage, with the industry. So I can close here. So again, Philip and Dominic, was a pleasure to host you both. I can see it was very well received. So it's a very important topic. And again, I thank you again for your time and for sharing your expertise. And I wish everybody a good afternoon. I'll see you next time. Bye for now.
Thank you, everyone, and thanks for having us.